Hello guys, hope you're doing well, and as always, if you are new to my channel, I would request you to subscribe to my channel. Thank you. All right, the problem at our hand today is that we have a pipe assembly. Okay, we have a pipe assembly which is subjected to the 80 Newton force. Okay, this pipe assembly is subjected to 80 Newton force. This pipe assembly is in 3D space. Okay, you need to calculate the moment of this force. Okay, this force about a specific point which is B, about this point. Okay, so we need to calculate, since it is a 3D problem, so we'll be calculating the determinant of RBC cross F. Okay, so to get the moment about this point B, which is MB. Okay, so here we have enlarged our figure, and let's start by first calculating the coordinates. Okay, so what will be the coordinates of point A? It will be 0 0 0. What will be the coordinates of point B? Point B is basically coordinate along the x-axis is going to be 0. Its coordinate along the y-axis is 400 millimeters, which is zero point 0.4 meter, and along the z-axis it is lying on the xy plane, so it is basically 0. Okay, so this is the coordinate of point B. What will be the coordinate of point C? If you look at it, first of all we move along the x-axis, which is this x-axis. We see 300 millimeters and 250 millimeters. Okay, 300 and 250. So the coordinate of x at point C is 0.55 millimeter, which is 550 0.55 meters, which is basically 550 millimeters. Along the y-axis, if you look at it for this point C, it will still be the same 400 millimeters, which is 0.4 meter. And along the z-axis, since this is our xy plane, along the z-axis we are going below this plane. So how much we are going below is 200 millimeters. So this is minus zero point 0.2 meters. Okay, so we are calculating it in meters. The other thing, we have coordinates of B and we have the coordinates of C. We can easily calculate our position vector RBC, which is final coordinates of C minus the final coordinates of point B is 0.55 minus 0I, zero point 0.4 minus zero point 0.4. It is times J, which means it's along the J, it is basically 0, not along the y-axis. It's taking 0. And along the z-axis, it is minus zero point 0.2 K. So the resultant coordinates of the position vector RBC will be 0.55I minus zero point 0.2 K meter. This is what it is. Now force F calculation, we have to be very careful. This is our force F. If you look at it, this is our force F. Okay, so for this, first of all, you can see for this force, you can very easily say over here is that this force of ours is basically starting from this point C. One of the components of this force will be, if you'll be very careful, and let's basically calculate it over here. And one of the components will be basically from this point to this point. We make it a slightly different color, will be better. Okay, so one of the components will be from here to here, and you know its direction will be this. The other component will be again from here to here, and its direction will be this. Another component along with Z will be from here to here. Okay, and whose direction will be, if you look at it, it will be like this. Okay, so these are the components. So for this, if you see, we will say force F will be equals to 80. One of the components, since this is lying here, so we can move from here to here. If we move this component, the vertical component first of all of this component, force 80 Newton will be 80 sine 30k. Okay, it's basically 80 sine 30k, but a minus sign is coming. Why? Because this sine 30k for magnitude 80 is on the negative side of the z-axis. This is positive z on the top, we are below the positive z, so this is minus sine 30k. The other components will be for I and j will be respectively, if this is sine 30, so this line will be cos 30. So we will say 80 cos 30. The x component will be this one. So 80 cos 30 sine 40. And since this axis direction is the same as positive, so we take it positive. What about the J component of this force? It will be again 80 Newton, cos 30, cos 40, 80, cos 30, cos 40. Since this direction is along the positive y, so it's positive. Now just multiply these values, you'll get this force F, and you have already calculated RBC, and this is F. What you do, you place it in your determinant for the moment to get RBC cross F, IJK, and you put the RBC values, position vector BC, the force components here, and you multiply them. And you basically take the determinant of this in your calculator. You will get RBC cross F as the moment B, which is 10.6 I plus 13.1 J plus 29.2 K. I hope this solution will assist you, and thank you very much, and you have a wonderful day.